So I'd run across something on Reddit where somebody was wondering if somebody had created a solution method where I guess if you don't like F2L, where you just solve the first face and then skip F2L and then just orient the opposite layer using the regular OLL PLL algorithms and then see what happens. So I guess we're going to try that on a few solves here and see what happens. So, all right, so we'll try white here and we'll just solve the first face like it's a normal solve. Maybe not that normal for you guys. Okay, so there's the white face done. Now, the next thing you'd have to do is get any yellow pieces out of the middle layer. And I'm assuming the only tool he's going to do that is like the same beginner method thing that you would use to get a piece into the middle layer. So I'm going to put this piece into that slot where there's a yellow piece intentionally. So hopefully, all right, so now we have yellow pieces out. So we've done our orientation. And that was relatively simple. So now we have permutation to do. Is this a normal permutation? Actually, this looks a little weird. So no, it is not a normal permutation because we have two edges that are swapped, and that's not a normal PLL. And that's because there are two edges in the middle layer that are also swapped. So we can do R2, U2 3 times, and now we've got this to a normal U perm, which we can fix, and that would leave us the middle layer left to do with a horrible all edges flipped case and the dot case. So yeah, pretty terrible, but so that's what you end up with. So I don't know, maybe I should have been counting moves. So now you could find other ways to do something similar to this, like if you wanted to just have no regard for piece placement for the two opposite sides, you could have it so you'd have to permute both opposite sides, and you could even go so far as to just segregate like a pair of colors and not just one color. So you could have something where you start with so we've got all this whole side either yellow or white, and then we could do the same thing on the opposite side. Let's see. Can we? Okay. So now we've got two opposite sides that are constrained to two colors, which we should be able to fix relatively simply. So what kind of permutations are we going to get? Well, that one came out kind of normal. And now we have the other side to do. Let's see, what do we have? No, we got that case again where we have to swap to. Now we can do the middle layer normally. But again, that horrible case where all of them are flipped. So, I mean, it's not particularly optimal, and that's probably why nobody's touched on that. Roux, which solves, sets of opposite sides, still has some efficient things to do, even if you have, say, 4 edges flipped, where you can fix that quickly And when you have them all in the middle layer, that's not very easy to fix those quickly. So that's probably why there isn't a solution method like that.